Hello, viewers. So, welcome to another day, day 3 of Java MGA game coding programming. Today, if you missed the 2 streams that we had about for a day ago, basically what we did is we're creating a Java game using libgdx with support for Android. Now, the whole goal of the game is basically a survival wave-like shooter, and that is about as much as I could reveal as of today. That being said, last time that we met, we were working on the manager class, and what the manager class did was it made sure that it was able to manage all the textures that we give it, because the amount of resource that we're going to load is a lot, and we want to make sure that we don't load the same resource twice, therefore causing a ton of memory usage. Today I have one of the people that I'm working with. His name is Frank. He was on the stream for day 1, where we were testing out our very first stream. Frank, if you want to say hello, you can.
Hello, I am Charles' newbie partner.
Okay, that works. And so Frank will be joining us today for our session, and he will basically be asking any questions that he might have or anything that I have missed. And one more thing is, today we will be working on the Sprite handler as promised in the last video. So basically what we had is we had managers that managed the source classes. In other words, they were the classes that were able to make sure that we don't waste any resources, and we were able to unload any texture or any source at any given time. But the problem now becomes, what happens if we unload a resource at any given time, and what will happen to any object that is connected to that resource? Well, if you look at what we ended with last week, you will see, well, not last week, last 2 days ago, you will see that what ends up happening is, as for libgdx anyways, it would be a dark square, and that is because we dispose of that texture without telling Sprite that is associated with that texture is that the texture has been deleted. Now, that being said, libgdx does provide a way for us to circumnavigate this, because if you look at the libgdx documentation, you will actually see that libgdx has a specific manager, and that manager is called the asset manager. Now, in this point in time, one might ask, why are you creating something so similar to Asset Manager if Asset Manager seems to do everything? Well, there are 2 reasons why we're kind of making our own manager. Number 1, it is because creating this manager allows us to understand how said manager works. And number 2, because if I could show you guys the actual code for the manager, asset manager, you will see that the asset manager that libgdx created is massive. Not this one, this one here. And so the guys at libgdx created a very good system, an incredible system for loading assets, and I probably can never create such a massive piece of code in this short amount of time, but it is so massive, in fact, that it is basically be able to handle anything that you throw at it, and our game does not require such a large capacity. Notice here in its constructor, it loads a pix map, a texture atlas, a skin, a particle effect. All of these specific loaders, as libgdx calls it instead of managers, are unnecessary to us. And so we're kind of creating our own custom one because A, we want to learn about this process, and B, because asset manager that is given in libgdx is a lot more complex than what we need. and it is probably faster for us to code the thing than it is for us to worry about it. And the other thing is, Asset Manager cannot allow you to unload a specific texture or just resource in general at any given time. It actually has a internal check to make sure that all the objects that contain said resource has actually let go of that object prior to disposing the resource. And so we want to make sure that we're able to bypass this thing by having our own custom manager, and because of that we also need a Sprite handler to take care of the mess that we might create. So it's sort of two similar ideas but tackled in two different ways. Alright, so now today we're going to create the Sprite handler. Much like the manager class, it is actually very similar. You need to have a base class, and then we'll extend that base class. So that's what we're going to do. We're going to create a new class, and we're going to call that the handler class. Now that might be a little bit different from the general usage of handler, and the reason why we're calling it handler is because it kind of handles any texture errors for sprites, and so I'm calling it a handler class. Now I'm going to open up a C++ code here because I usually use this type of setup for a lot of games that I'm making that are short or small. And so I'm going to port my C++ code into Java, and hopefully once I do, if I have any upcoming Java projects, then I could just reuse this code, assuming that I don't require Asset Manager given by libgdx. Alright, that's basically the introduction. Hopefully now that we're done with that, we could get into actual coding. That being said, Frank will probably cut in at some time for any questions that he may have, or also things that he wants to share. Alright, so without further ado, let us start. Yes, Frank, did you want to say something?
How is the handler class different from the manager class?
Okay, so basically, I think I sort of covered it in day 2. We have two different types of classes in basically any type of game library, in a sense. There's usually a resource class, as I call it, and then a container class. And so the resource class has the texture, the sound, and anything that is associated with data. And so it will only contain data files, while the container classes will contain anything else. So for example, texture is the resource class for an image, and it will only contain the bits or bytes or information for that image, while Sprite will contain the location, the integer location, the vector location relative to the screen of where that texture should be outputted. And so what we're doing is manager is essentially taking care of all those resource classes, while handlers will take care of all of those container classes. If that makes sense. All right. Thank you very much, Frank. Hope that helps. Let us continue. So with the handler class, we basically, much like the manager, have a internal struct, or in Java equivalents, we're just going to create a protected class, and it's going to contain three things. First is the name of our container's unique ID. Second, the file name of our container's associated texture, and 3, the actual container object. Yeah, no comment on that, so I'm going to do that right now. Alright, and one more thing is we want to create a generic class, or in C++ terms, a template. Class, let's just call it class T. And let me check something here. move this one forward. Oops, don't need class. And as I type this, one thing I want to make sure to note is that we are not striving for extreme optimization, and as such sometimes you'll see things that are not commonly used in lower end engines for C++ or C. One prime example of that is if you look at our texture manager and eventually our handler as well, we actually hold, the manager itself, we actually hold a map that has a string pointed to a resource, not an actual array. So what people usually do in C or C++ for lower end languages, correct me if I'm wrong, but what they do is they kind of hard code the position of where all the resources are located and then loaded in. And that way that would conserve a lot of memory and also not CPU usage. Just, what do you call it? Dang, I lost the word. But it basically saves a lot more processing power because of the fact that you're hard coding the position of your data directly into your game. And this is usually used if you look at Doom or any old games. They're always built with that in mind because back then the processing power was not strong enough. Luckily for us, this game, the size of this game, and also just computers and phones in general nowadays are much more powerful, and so we don't need to worry about stuff such as that. So hopefully for people out there that are very sensitive to optimization, I'm sorry, but if you want, I don't know what I can say. All right.
Sorry if you were talking to me. I was talking with the roommate real quick at Lambo. So.
Nope, don't worry. I am live streaming, so.
Okay, you are creating a hash map for handler class. I see.
Oops, should make that. Yeah. So what we're doing is this map, much like the manager, will hold all our resources. So we're gonna right click on that, and instead of not right click, just hover over it, and instead of me typing the entire import, I'm just gonna import the whole thing automatically. Alright. And the container class will contain 3 objects: the string name, like I've talked about, another string, and then the container itself. And so the file name is the file name that is associated with the sprite, and we'll utilize that later to identify what texture has been deleted. And so later on we'll see that we'll give it a special property for handlers, that we could attach a manager to a handler, and so that we could make the functions much simpler to use, and you'll see that later on in the stream. Right? So now that we have the map and we have the struct implemented in, we're going to now do the container, the protected kind of internal helper function. And what this does is it will get sort of the container located inside linked hash map. So it's essentially here, let me show you. It's probably much faster for me to do this. Actually, for the sake of simplicity, what I'm going to do is I'm going to pretty much skip this function for now, because this function is not very easy to understand, and I'm just going to comment that out, and I will work on the other functions such as the constructor, and we'll come back to this function when everything looks much more in place. So a handler constructor will have to call 2 things. First, the default file name, and second, the default container. So what we're doing is we're essentially telling handler, when we create a new handler object, that we must have a default handler, a default sprite or default container object that handler can point to no matter what. So that's very similar to the manager class, where when we create the manager, manager will require them to create a default resource, so that if anything goes awry, manager can point to that default resource. So if you play any Steam games such as source engine games, you might see the infamous purple textures or the error models. Well, that's essentially what we're doing here with the default container and the default resource. And so attempting to port the C++ code into Java, much like the manager class that we are doing. And so since we have a default container that we have, we need to create a default container. I'll call that public variables. Right. So that is right here. And so this will hold our default container. And so in our constructor, we will basically say that the name of our default container will just be hard-coded in, and we're gonna call that, or actually, might as well pass it in as well. Like so. There we go. Is equal to default file name. I could get that container.
Is container a reserved word?
What do you mean?
Oh, as in, like, is it a built-in function in Gradle, I guess?
No. Not in libgdx, no.
Oh.
At least not that I know of.
Because when you initialized private container default container in the header below linked hash map, isn't the black word before the blue word supposed to be like the data type or something?
Yes.
So container is a data type?
Container is a class. So it's a class in a class, if that makes any sense. And so it's in Java, I believe it's called a complex data type. And then anything else that isn't complex is a primitive data type. And so what we're doing is we're creating a helper class in a sense, where we're saying if you're associated with the handler class, then you have access to this special class called the container. And the container class has these properties.
I see.
And so I'm gonna put this as public because I don't need it to be encapsulated, as since it is a helper class, and the C++ version has it as a struct, I don't really need it to be safe from other people's usage. since no other class except for handler and its extended classes will have access to container. Like so. So we just created a constructor, and so now I don't need to do all that messy stuff. I just call that constructor. Hooray for extremely long names. Alright. And that is just perfect on the 80 character mark as well. So that's great. Alright. So now that we created the default container in our constructor, that will be it for that. Next we have the... Okay, so if you don't know, Java does not actually have a deconstructor, because we basically don't know the lifetime of any objects, as Java has its own custom garbage collector. That being said, however, we can create functions such as dispose and libgdx that is called whenever we want to get rid of data, and we want to get rid of memory usage, and that is basically what we are calling in manager class from last time. We had a dispose function somewhere in here. Here it is, dispose. And so that is sort of the workaround for manual deletion of objects in Java. Alright. Now this function here basically is called whenever you want to get an address to the default container. And so what I'm going to do is, since the default container cannot change, we are going to make it final, so that once we created the default container, no one, including ourselves, can change the default location, a default object, and the default file name for the default container. And so now we can create a function in Java to have access to that without worrying anyone that someone might get that. Oops. Yeah. Here. Okay, so when I mentioned about this class being by its only in this handler class, I sort of maybe didn't give enough information. We do pass it outside of this class, but we're kind of treating it as a struct, a very simple struct. So yeah, it might be a little bit different from normal Java usage, but since I'm importing this directly from C++, there might be some differences from that, and hopefully we'll be able to change that code as we go along. Alright. Next is we have a abstract function called resource deleted. Now this function will essentially be called whenever we want to tell handler that we just deleted a texture. If we deleted a texture, then we want to make sure that handler will be able to tell and then do whatever it needs to do to make sure that it updates all the sprites associated with that texture. Boolean abstract. And so this will be the function that whoever extends this handler class will need to override. See here. Did I mix up the keywords again? See what the complaint is? Oh, that's right. I need to call this class abstract. All right. And so now we have the delete container. So this is basically going to be our mutators for the linked hash map, because the linked hash maps contain all of our container classes. So it's pretty important. So we want to make sure that we don't want to just give it to whoever extends this class, because who knows, they might accidentally delete the entire container, and that is not the whole point of a handler class. The whole point of a handler class is to make sure it can update any container class that exists, not to destroy them. So I'm going to do public again, public boolean delete container. And so we're going to need to pass the container name, the custom container ID. But I call it container name for short. Well, longer, actually. Because if you call it container ID, it sounds like it is an integer. In fact, it should just be the name of the container. And since it's essentially the mutator, what I'm going to do is I'm going to call it that. So, Frank, any questions so far?
Container is just something that holds methods to access the resources in the manager class, right?
Do you mean the container class that I've defined inside handler, or do you mean the container as in general?
Oh, I mean the protected container class.
Protected container class. So it's basically a class that holds information together and regarding that specific generic container. And the reason is because if you see here, we have a linked hash map, and so that linked hash map, which has a unique string, is connected to a container class. If we didn't have that and we only had individual strings, file names, and containers, we'll have to have multiple linked hash maps, or just multiple tables, just to kind of link all this data together, when we could kind of just package everything in one class. And so that's the whole point of this container class.
And then in the container class, you basically initialize 3 variables.
Yes.
Then in the container, so then you create another class, and then in that container class, which has this dot whatever, what does that do?
Here?
Yeah.
All right. So this is a keyword specifically for when you pass in a function with the same name as the members of that function, of the variables in that class, like name, and then you pass in a function that also has the name variable. What you have to do is Java will have two types for that same keyword. One is relative to the class and one is relative to the function itself. So if you use this keyword, it lets Java know that you actually want to access the variable called name relative to your class, while name in your parameter is just called via the keyword itself.
Then why don't you just use another word for the parameter?
You can, but because when you type in stuff, when you call this constructor from another class, if you're using a good IDE or just an IDE in general, they actually copy and paste this parameter in as your helping thing. So if I was to do this, and I said new container, if I didn't do any misspellings, my bad, new container See if it pops up. Does not pop up. But some IDEs, what they do is it would actually pop up a help list, and that pop-up will actually be that specific function. And so people will actually see string name, file name, container. And so help whoever's coding knows what that string and what that container should be.
So T container is just whatever you're passing into the general handler class.
Yeah, it's the container object.
Oh, okay.
In fact, I should probably call this container object. Like so. So that way we won't confuse it with the container class. And yes, you're right, I could name the parameter some other name, but this name feels the least confusing for people to understand what to pass in. And when they access the objects, it feels the least confusing. There we go. And so the delete container will be our getters and setters for whatever is inside this linked hash map. And we just give it that unique string ID. So we basically have the name and then the container itself. And then we would use this function that's yet to be defined, and we'll check whether or not the container exists. If it does, then remove it. If it doesn't, then return false. Let's see if we have the container exists function. Here it is. Let's see where we should put that in our file so it doesn't get confusing. Let's put it in here. So anyone who passes the name of the container will be able to find out whether or not that container exists. We need to find the Java equivalent of this, which I believe is just key set dot contains. So if it does not equal to true, oh, my bad. What I can do is just call this function and then return it. So it's sort of a function that cuts corners, and we could just have to call our custom exist function here. In fact, I think I could do the same thing for our texture manager, because I did the same mistake here. Manager class, resource exists. So I can just return this. That is an unnecessary if statement. There we go. Shorthand function to check. And so I sort of covered this from last stream, but essentially we're using a linked hash map instead of a standard hash map, because with linked hash maps it's ordered in such a way that you could actually iterate through it every time with the same order, and that might become useful later on. I should probably talk to you more, Frank.
Well, I have a friend I'm meeting with on Friday, and he doesn't know anything about Java, and I'm gonna be helping him understand some things,
Uh huh.
and I'm gonna be using this game code as reference to help explain some things to him, because he's
Okay.
taking it next quarter, and he doesn't know anything, and I'm just trying to get him some general concepts in his head,
Mhm.
with encapsulation, polymorphism,
Mhm.
inheritance, things like that.
Okay.
But
Won't this be a little
so
bit steep for him if he's just starting off?
well, he's worked with JavaScript before,
Uh.
but it is a lot different.
Yeah.
But Java should be a language that you can start out with, but it just takes longer to learn if you start out with Java, in my opinion.
I think
Like, I think,
again
hmm?
it goes to the analogy that I had where it's not too much about the syntax but the conceptual parts of Java.
Yeah, that's how I feel about Java also. The syntax is very, very hard if you try to understand it, but
The
a lot of the concepts make sense now that you've like walked through and kind of explained some functions, but um for him, I'm also gonna explain to him how like an object oriented mindset is much different, uh because it's not as like straightforward basically.
really? Uh.
I don't think so. I think you gotta find out what you need and then
Hmm.
work around that. But with C++, plus plus, like I noticed that if I had, well, I mean, I guess with Java you could do the same, but there's a lot more different things you need to do before you actually start like getting input from users in Java, etc., like with the scanner rather than just CN.
Well, CN is just, it's sort of the equivalent though. It's not
Yeah,
that.
but it's just built in, I guess. Like you don't have to import it.
Well,
So,
yes you do. You
I,
gotta include IOStream, right?
oh yeah, I guess that's true. But yeah, I guess that is true. But for scanner, you have to create a scanner object
For
when you
scanner, you
use it.
have to create a scanner object. Yeah, because it's object oriented.
Yeah. So that's kind of like the mindset I have to give him, and I'm just wrapping my head around it now. So
I think it's because with C++, it's um, it doesn't enforce object oriented thinking, but it allows it. While
mhm,
while Java, it does enforce object oriented thinking to a certain extent. I think that's why.
mhm.
It's funny because on the first day I also said uh, object oriented thinking is not that complicated, and then you're saying the complete opposite of what I was saying. So
I think it is if you've been learning languages that don't really require object oriented thinking, because I mean, if you're just taking some intro classes at our college,
uh huh.
you're not gonna really learn that much about object oriented thinking because we're doing a lot of just kind of procedural things that are very time wasting in my opinion.
Really?
So just like creating salary tables or something. Like uh you can learn the syntax quite easily through Python. But for something object oriented, I think it takes more than that. It takes some reading, takes some watching how other people create a program or something. And it takes a lot more resources than I initially thought.
Interesting. Yeah. I personally I'm not sure how the our college teaches programming, so I only the only experience was with my Java professor, um, and I think it's a little bit different at the other college that I go to because with that college we did a lot more object oriented thinking, and perhaps it's just because of the languages that we kind of learned because you're doing C++, right?
Well, I took uh two Java courses at a previous university, but
Oh, okay.
I liked it, but I also understood it and it wasn't that bad, but I guess after learning it, I was like, okay, so what can I do with this now? And then we never learned in even the Java class how you can use these cool libraries to do these things and etc.
Oh,
We just learned some syntax, some like the three main concepts of Java,
mm-hmm.
arrays, and that's all. And then of
Interesting.
course data structures next to it. But I think that's what an intro to Java course is basically like. But
Okay.
yeah, we just weren't given like the knowledge of, oh, you can create a game by using these online libraries. So I didn't find that out until much, much later.
I do recall a stage in my programming time that I was confused on what to do afterwards, now that I learned this new language. Um, and I think what I did was I just bought books. Yeah. Um, and I started reading.
But you didn't read it like from word to word. You read it like, oh, what is this? And then you referred to the book, right?
No, no. What I did is I read. I think I was over my head because it said introduction for DirectX programming, and I was like, okay, introduction. I should be fine. I'm sort of good in C++. I should be able to read it. And when I read it, I realized that the amount of knowledge that I know in C++ is not enough, um, because there's so much stuff in C++ that's not learned in class, or just recent ideas, design structures that come up very often, but it's something that you don't see in let's say a school environment or in any tutorials that you could find online. And so when I read it, I was like, oh crap, what is this bitwise operator with throwing in close window functions? What is this? What is a sprite sheet? What am I doing? And and so what I eventually did was I went to the store and I bought another book called the C++ for Dummies Guide, and it was really thick. It was 9 books in one. And then when I read that, I was like, oh crap, I have so much syntax to learn. And then it sort of became a perpetual loop where I was trying to learn the syntax that I didn't understand, but then at the same time trying to learn this idea of creating a game, a concept, and just kind of being thrown around between these two, saying, all right, my concept is strong enough, but my syntax isn't. My syntax is strong enough, but my concept isn't. So I was kind of stuck in that perpetual loop for a long time. And I think eventually I came out of that when I realized that I had to create games, just start creating projects. Because as you create these projects, despite not knowing a lot of stuff, when you create that project, you realize that, you know, I memorize and I learn a lot more when I do hands-on stuff, and B, I actually learned something that even the book itself didn't write about, because I had to go find the resources necessary to create the project that I want to create. And so that kind of got me out of that loop, if that makes sense.
Yeah, yeah, it does. Basically just learning hands-on.
Yeah.
But I think it is complicated in a way that even when you try to learn hands-on, you're not exactly sure what you need and don't need at first, like that asset manager, how you're talking about how there's all these things that we don't really need. As a beginner, like you look through that code and you're like, what is this for and how do I know if I won't need it later? But I
Mm-hmm.
guess it's not that entirely risky if you just use it, delete everything you don't, like basically start from what you currently know. Like, oh yeah, a game needs players and
Mm-hmm.
objects and audio and stuff, so you can keep those, etc. and just add on later, right? Just add on
Yes.
whatever you do. So I think it's more like starting from what you know, and
Mm-hmm.
then teaching yourself by making the game and adding like onto the resources that you need by questioning yourself later in the project, I guess. Questioning what else you need in the
Mm.
code.
Interesting. Yeah. Um, I do recommend, though, if you have time, a book if you want to learn more about the process of creating games or just this idea in mind, because hold on, let me think about something here. I have to finish typing what I have in mind or else I'm gonna forget. Object, so I don't need that. Alright, so believe that book is, let me pull up the trusty web browser here. I searched it up somewhere online. Oh yes, Game Engine Architecture. This book, if you could see it, a lot of people start out just this idea of game design from this book. This book is pretty nice because it gets into the idea, like, what is a game? What do you need in a game? What should be involved in a game? And it's really good because it covers various aspects of what a game should be, and also at the same time it covers this chart here, which is a very nice chart. It covers a lot of conceptual stuff prior to getting into the code. And when we started this project, remember I told the group where I basically said a lot of the stuff that you learned isn't the syntax, but instead how to utilize that language, Java, in order to write the game. And so here is what I mean by that to an extreme extent. Like here on the base, we have the hardware, the driver, the OS, the third-party SDKs, sort of what we're using. And then you have the platform independence layer, and on and on and on. Now obviously our game doesn't need this much stuff, but this is what a full multi-purpose game engine will require or will need to have. So I recommend reading that book if you have the time.
Originally, when I started this game project, my objective was to be more familiar with Java, and I wasn't really interested in making games, but more to use Java for something else. So I thought making a game would be a good method of learning. I don't know if it is, but it really seems like it is because it starts from the design level. Well, not really design level, but like you start with resources, and then it's up to you on how you want to design the game with those resources, etc.
Yeah.
Whereas like taking a class, I don't think it really prepares you for anything.
No, definitely not. Yeah, that's good because you usually want to start working on some project. And that's why a lot of colleges as well, if you're applying to a college, hopefully you are, a lot of colleges as well do that, where they say they prefer having a finished project than no projects finished at all. Because when you do an actual project, you realize, oh crap, you have a ton more stuff that you actually need to do than you first planned. So, yeah.
So what else do you see yourself using Java with?
Java, I sort of do this. I personally am much more skilled in C++ because that was my second language that I ever learned. The first being C. And then Java was my third language that I learned. But what I see is I see Java as sort of the quick language that I could utilize. Because with Java, it's much more elegant in a sense that everything's object oriented. So I don't, such as the Swing library. If you look at the Swing library that's provided for Java, it creates GUI applications fairly quickly. But you look at C++, there are GUI libraries that you could utilize, but you have to set it up and you have to build the libraries, you have to compile it. It's a pain in the butt with C++. And so I use Java whenever I want to have fast and quick compatibility with other environments, because Java runs on the Java runtime environment, and so it's much faster in running in all different types of environments like Linux, Mac, PC. And if you go to C++, you realize, oh crap, you gotta do this platform independence thing where if it's Win32, if it's Linux, if it's Mac OS, and it's a pain to set up. And so I do Java if I want to create a small miniature project that is able to do what I need to do in a short amount of time. That's what I do with Java. Now with C++, on the other hand, I see it as a very powerful tool where there's a lot of things, because you're not technically restricted to that object-oriented design. In fact, you can do like singleton designs, or you can do what is it called, entity component designs. And so with C++, I use it when I want to get serious, and I want to create a project that is efficient, that is powerful, that is something that might not have seen before, that is essentially not limited or requires something outside of object orientation. And so someone just texted in chat saying, what kind of game are we making? To answer in a short fashion, we are creating a wave life survival shooter game that is targeted to the Android platform. We are using libgdx to create such a game. That being said, I can't reveal too much information because we are creating this game besides just myself and Frank here, who is joining me on Skype, but also several other people as well. And so I'll need to get permission prior to sharing the amount of information that I could give away. But essentially, it's a wave life shooter. And our goal is that we're able to finish this game within 4 weeks, and we're live streaming for the sake of documentation, as well as getting people from our group to ask questions, or you guys can ask any questions, and I'll try to answer to the best of my knowledge through this process. And as of now, we're creating the handler for our game. I'm not going to get too into detail because I've kind of explained it multiple times yesterday, the day before yesterday, as well as today. So if you want, our videos are archived at Programming Included at YouTube, or if you can catch the archive videos at Twitch before they go away, it is also in this channel. Yeah, that's basically the introduction. Hopefully that answers your question, and maybe some other stuff as well. Okay, Frank, sorry, went on a tangent there. Where was I?
You're talking about how C++ is for you to get serious.
Yeah.
I was
man.
wondering, can you, if you learn how to make a game through Java, a mobile app game, could you use that knowledge to also make other kinds of mobile apps that aren't games at all, that are like related to maybe Google Maps or some sort of hardware related, like a quadcopter navigation app or something?
For Java?
Yeah.
Okay. That would be an application. And so when we use like libgdx is designed for games, because if you look at the libraries that it has, there's textures, there's sprites, stuff like that. But theoretically speaking, and if you want to, you could utilize libgdx's capabilities of Android and use its specific porting capabilities and create that application that you want that isn't a game. And you can then use libgdx's drawing abilities to draw the GUI that you want. In fact, that's sort of the workaround for C++ in some ways. For example, if I wanted to create some game in C++, or no, not game, just an application in C++, I use SFML, which is designed for games and also applications. And so there's nothing wrong in you doing that, but if you go to Google and you search up Java libraries, you could probably find a library specific for Android development outside of the realm of game design. Because game designs, you usually have libraries that are way too complex for what is needed or necessary for a normal application, such as a matrice. You probably don't need a matrices in a normal application unless you're drawing three-dimensional graphics. Yeah.
I see. So, when it comes to other libraries for non-game related mobile app development, they're probably overcomplicated and you'll have more than you need, but you'll definitely have enough for what you need.
Yeah. In
Okay.
fact, I'll search it up right now to see what we actually have on the market today. Oh, of course, there's the Android SDK itself. Forgot to mention that. Um, but the thing with Android SDK, as I always tell people who want to start programming on Android, is that um, much like OpenGL for C++, you have to do a lot of yourself by yourself. You actually need to code the very low level stuff, and that takes a lot of time. Um, and so a lot of people come up to me saying, "Hey Charles, I want to create an Android application and I'm using Android SDK." The first thing I tell them is, "Are you sure you want to use Android SDK? And how complex is your project?" Because if you use Android SDK, chances are you're going to take a lot of time trying to optimize or trying to figure out the whole process of vertex buffers and trying to throw in the amount of GPU calls or just amount of drawing calls you need. And there's a lot of optimization that is already done by a lot of people. So usually I tell them by the end of their conversation is you try not to use Android SDK unless A, you want to learn the underlying mechanics of how Android works, or B, you want to do something very simple like draw a circle and press it or something like that, because it takes too much time. By the time you're done with the classes that work with Android SDK, you're pretty much done with the game if you use a Java library. So, yeah.
So, you know how we were talking about how if we're applying for college, they prefer finished projects because I didn't want my project profile to only consist of mobile app games. I wanted to be a little more diverse than that and have maybe like a navigator app that I made for my quadcopter or something.
Mhm.
So in that case, um, would that take much longer than a mobile app game to create an app like that?
Mhm.
Or would it take relatively the same amount of time, but just a different methodology, which should take more time because you have to learn it? Or
I think what I
or is
did
it quite universal for mobile applications?
what I did was I learned the underlying mechanics of how everything works. I got the broad picture. So I first, I did it in C++. I went to OpenGL and I started learning OpenGL. Now, if you learned OpenGL, sorry, Sorax, I will answer your question in just a moment. If you learn OpenGL, you will find out a lot of underlying things that drawing mechanics, vertex buffers, stuff like that. But then you eventually find out it is a pain in the butt to work with, like I mentioned previously. But when you learn that, you learn a lot of details. It's much like, let's see, what is a good analogy? It's sort of like doing math or doing physics. You learn the reason why something works in physics. Let's say you learn Newton's second law, and you learn how to use that equation. And then you learn why that equation works, and then you move on. You don't actually, you know, calculate how fast a rocket is going using Newton's second law. You don't use that because that's ridiculous, the amount of calculation using only that specific law. And so you learn other stuff. You learn more complex stuff that's built off from that existing idea. But as long as you have that foundation, when someone asks you, how did you use linear momentum? How did you come up with linear momentum? You can say, well, I know how Newton's second law works, and so I'm going to say I could just go check out how Newton's second law works and then slowly derive that idea to linear momentum. And for those of you who don't know physics, linear momentum is derived from Newton's second law. In fact, Newton actually used linear momentum to derive Newton's second law. If I get that wrong, let me know. All right. Hopefully that answers the question. Basically, oh wait, no. What was the question again?
I guess it was like, how difficult is it to create another mobile app that's not related to game dev
Mhm.
if all you've ever done was game dev?
Um, I'll tell you this. I personally went into game design because game design touches a lot of deep stuff, a lot of high-end, high-tech stuff. You look at some computer science papers done in colleges, and you realize a lot of them are just optimization for drawing three-dimensional graphics or something like that. So I went to game design because it usually has a lot of high-tier new ideas and concepts, and stuff like entity component systems you don't think of that often, or singletons, you don't think of it that often unless you get into game design or you get into some deep some company. So yes, I would say if you want to learn with a lot of flexibility, then you learn game design, because game design works with the GPU level, the hardware level, and then you also have to learn the abstract level of how do classes work together to have the logic of the game, if that makes sense.
Yeah, that was good. That was well put, man. Thanks.
Okay. So Rex, for your question, I know it's a bit random, but what language would you use to make an AI that could have a conversation with their user? Oh, right. Let me think about it for a second. See if there's any information on that. Now, what you're covering there is two things. I personally haven't done too much on that subject, but I do have a book on that, but it's for C++, sadly. And then essentially, what you need is... Oh wait, hold on. Do you mean by text input or conversation as in talking? That's important. Because if you're talking to the AI, then you will need to with talking to the AI, you'll need to have some way to parse that conversation and change it into readable language by the AI. If it's just text, then you need to have something to parse that text into information that the AI can utilize. So I'm not entirely sure. Text input. All right. So I would recommend C or C++, some language that is much more closer to the hardware, because with AI, what you usually need is either trees. Let's see, what do you call that? Do you remember the name? Yeah, some type of tree in order to sort of map out the grammar of your structure and stuff like that, and for it to learn stuff. And so you need to have some kind of speed involved. And with C++, it's much faster than compared to Java. And also you have metaprogramming available for C++. If you don't know what metaprogramming is it's essentially a way for you to edit the code while you're running the code. So one example of a possibility for metaprogramming is Lua. Personally, I am using Lua in my C++ project that I'm currently porting to Java, just some parts of it, not the Lua parts, that will read Lua and then convert it into C++ and then run it. So if you were to create an AI, and let's say that AI needs to store information, or some kind of complex code, you could store it as a Lua file instead of, let's say, a typical text file or a typical XML file, and then it'll be able to parse that Lua file and run the actual code inside Lua, which is much more powerful than, let's say, Java, which is fixed to Java itself. Other than that, if you're looking into libraries for that, you might need to check into, let's say, grammar libraries or any language libraries that deals with parsing text, because that's one big thing that you need, as one of the layers for AI is for the AI to understand what you're giving it. And then afterwards you need it so that it goes the other way, where AI outputs information that can give to the user, and the user actually understands what it's looking at. So hopefully that answers your question. And the internal workings of how AI works, that is completely up to you how you want it. There are some libraries for the internal workings of how AI works, but usually people just do it by themselves, because it's a topic that not many people cover unless they want to do AI for games. And AI for games, they're usually just algorithms. So yeah. All right. Cool. And just as an update for those of you joining in, I am currently porting in a code that I had from a previous project in C++ into Java, so that way I don't have to rewrite everything again. You're welcome, good sir. Oh, Frank, I forgot to tell you, but on stream people were asking me questions. Yeah.
On TV? I mean, Twitch?
Yeah.
Okay.
It must have been weird, like just talking to myself, and then, yeah. Hopefully you knew that I was talking to someone, or else it would be awkward.
I did.
Okay. Alright, so now I'm creating a function called get associated resource, and this is again another helper function that will be called later on for an extended class. I added in this function after I finished coding everything else because I realized that we had to delete, or we had to change all the textures within all the sprites, and in order to do that we need to get all the containers that had that same texture. So that is basically the reason for this function in a nutshell. I need to start commenting my code, or else I will have to do that off stream, and I do not want to have a whole day of commenting my code, so I'm gonna add that in right now. Get the containers.
Wait, so a container associated resource isn't, why can't you just what's it called, pass it by reference?
Hold
Like
on.
reference
Pass
variable?
it by reference variable. What do you mean?
Because you said like something about texture or container changing from the sprite or something.
Well, the thing is, I could pass the container. I could pass a array list full of the container objects and not the container class. Whoa, Frank, you okay? That
Yeah.
was a loud noise. Okay, I could pass the object, but that would be. You'll see later on why that doesn't work, because if I change the default texture in the container object, I need to change it in the file name as well. Yeah, so I need the whole container. And since Java is passing these objects as sort of pointers in C++, we don't actually copy the entire container. We just get pointers to that container object, so we're not using too much memory. Alright, just gonna hopefully I don't have to change too much. Yes, I do. Auto keyword, can't use that. This is basically useless to me, so I'm just gonna type it again. Oops. So we create a new list. Container. What should we call this? Cont is equal to new list. Okay, so Frank, here's another dilemma that I realized. Every time someone joins this Twitch stream, I kind of am tempted to do a whole introduction of how our project works. What should I do?
Oh, are they asking about it? Because I don't see anything in chat.
No, not asking about it, but I want to say it because I am worried that they will have no idea what I'm doing.
Oh.
What is the solution? I really look at Twitch The only time I do Twitch is if it was like SGDQ or HEDQ. Other than that, I rarely use Twitch. But
Well,
hopefully
the
that will
good thing
change.
about us documenting it is that we can go back later and watch it. So
Yes.
I think if someone wanted to understand what we're talking about in context, they could just watch it.
Okay. Alright. Do you remember the syntax for iterators in Java? Because I have not memorized that at all.
Is an iterator just a for loop, basically?
Yes, sort of. Not really. It's basically an object that replaces that thing that you learn in the beginning of a lot of programming classes where you use integers instead of iterators. But with iterators, it's much more powerful because A, you could just call a function, and B, there are other... Here, let me just show you. If you go to linked hash map iterator, there are other functions inside iterator that you can use to help kind of make your life easier on you. So I'm gonna use that. Yeah, personally, I don't like the fact that Java doesn't have the auto equivalent keyword for creating iterators, as at least none that I know of, or has not been taught to me by my instructor before. Alright, Frank. Quick question. What are you doing? Because my ears are starting to hurt.
Oh, sorry. I didn't know it was that sensitive. I'm cooking ramen.
Ah, nice.
I'll mute it real quick.
Yes, folks, ramen, the best college food that exists.
More like the only college food that exists.
Nice, nice. It has next. So what I'm doing is I'm creating an iterator to go through the entire container, and then we're checking if the containers have the resource file name. If it does, then we throw it into the array list and return it. If not, then we skip it. So if the file name is equal to the resource file name that we give it, then push it into our return value. Now, I sort of said this in the beginning of the stream, but since it's been a while now, I'll repeat it for those who are still on the stream. Basically, our engine is not going to worry too much about optimization, and so I'm doing stuff like this, where I'm comparing a string. Now, if you're used to C++, that is usually not a good idea, because you do this hundreds of times and you're trying to match the string word by word. That takes up a lot of resources. But luckily for us, computers nowadays are pretty powerful, and Android devices are as well. And so we're not going to worry too much about optimization. That being said, if I was to redo this in C++, I would probably have a much stricter standard. So we're going to have a container holder here to hold our object, because if I recall correctly, if we call it.next, it would give us the next element, and then if I call it again, it will actually give me another element in that hash map. So I don't want to call it multiple times. See if that is correct. Yes. So now that we're done, we return the actual array. There. And I think that is it for the handler class. Let's double check. There are no deconstructors in Java. Lifetime of objects in Java are handled by Java's garbage collector. So no need for deconstructor. We don't need a custom deconstructor function to manually call, because we don't actually have any resources that we need to release at that specific time. Do we have delete container? No, we don't. Alright, I'll add that. We have the add container, get container. Alright, that's the last one. Delete container. So delete container is basically your average setters and getters for our linked hash map that will hold all the container objects. Okay, just for the stream, what instant noodle are you eating?
Shinramyun.
Okay, no idea what that is.
Spicy Korean? Something like that.
Okay.
But wait, why am I watching? I was watching your Twitch in full screen instead of the Skype in full screen.
Yeah, Twitch has a little bit of lag.
Yeah, no, that's why I was like, what? Shit, I just not realized.
See what the error is. Oh, I did add delete container. What am I doing? Alright, then we're done with the handler class. Alright, one more class and we'll be done for the day. So what we need is a class that extends handler and actually works with the Sprite classes. So we're gonna do that now. We're gonna call it Sprite handler. I might rename these two classes later, because if I recall correctly, libgdx's handler name is used for something else. I will double check on that. Alright. So this is the C++ code that I have for most of my C++ games. And
So
I'm
is
just,
that like a framework you use? Oh no, that's just another game called Case Creator or something.
no, this is actually another framework that I use that I learned some time ago, and I've been sticking with it since. That being said, I haven't actually released the source code on it, so whoever's viewing the stream gets the benefit of, well, looking at the source code. I might release... Okay, spoilers for those of you watching. This C++ project, I will actually release this in the near future, and it will be open source. So if you're interested in C++, I will work on this project sometimes on this channel, and I will at some time release the GitHub for this project. So
when I create the player or enemy class, what do you want me to reference
what do you
to
mean?
like help me create the class?
Alright. Do you have the UML open?
Let me check. No, let me open it right now really quick.
So for those of you in the stream, we actually have a organized layout of how the game should be in our Google accounts. Sadly, I cannot show you guys that because it is sensitive project information that I cannot share unless I have enough permission.
Okay, so I have it open. I know what it's supposed to do basically, but oh, So I literally just write code that does what it says in here.
Yes.
Okay. Does not contain.
Okay, you know what?
Okay.
I will actually show this in the stream because I did do it on day one. So, I'll do it. Design overview. Okay. Hopefully it doesn't show my... Okay, it does not. Good. I was worried it would show my Google account, which I don't want people to look at. So, you're working on the player, right?
Yep.
Alright,
I'm getting a call. 1 second.
alright.
Hello?
Alright, well, Frank is doing his thing. This is kind of what it looks like. Since we have multiple people working on the project, what I did was I typed out a brief pseudo information on what each class should do, a design overview, so that everyone can be on the same pace. And obviously, I didn't write everything because I did have personal meetings with them so that I could talk to them about the classes that they're working on. So we use UML to write the actual design of our game. There we go. Sprite handler.
Okay. Friend just drove in from SoCal tonight, so
What?
I will leave and I will watch this video over again once you upload it to YouTube.
Alright.
And thank you very much, man. Honestly, you've been very helpful.
You're welcome. Hopefully,
And,
I don't do anything stupid on stream, but hopefully, the archives will be there when you're not here. So.
okay. Yeah, if anything, I'll just check tomorrow.
Alright, cool. And
Okay.
I'll finish up the Sprite handler and I'll call it a day here.
Okay. All right. Have a nice night, man.
Alright, you too. Goodbye, good sir.
Bye.
Alright, so now I'm all alone. Boohoo. Just kidding. Gonna do final things and then we'll call it a day. Now that I don't need to talk as much, I'll talk whenever there is something that is new, and otherwise I will be quiet because I need to drink some water. See if I could get some thing here. Alright. Let us continue. So the Sprite handler has a constructor. Now this constructor will need to pass in a default sprite to the handler so that if anything happens, handler will point to that default sprite. So as always, we need the default container name, the default file, and the sprite itself. I believe libgdx has a sprite class. Let me see here. Let's find that here. Sprite, batch, and texture regions. And that class is right. Oh. Huh. Let's use Sprite. Here. So we have the Sprite class. Here it is, and this is the source of it. Quite large. Not gonna go into details of how it works because this is specific to libgdx, and whatever happens in this class, I don't know how their internal thing works, but they should provide the functions that are usually the same for all almost all game libraries. So now we need to import this. And so this will be our kind of overridden constructor, and will provide a default constructor for us lazy people who don't want to type the whole thing every single time. And I'm just gonna call the overloaded construct custom built-in things. So we give it a sprite. Let's call the default container name to be error sprite, and default file name to be let's see, well, that file name will be the error text. So actually I'm gonna do static final the name of this thing, essentially. Call it container name. Call it Sprite. And then errortext.png will be the name of the file associated with error textures. And so what I'm doing here is I am essentially writing the default stuff as a final string, a static final, so that anyone in any place can find where the default final values are. That's hard-coded into the code. And also, if we have, let's say, some parser or something later on post finish of the project, we will be able to read these names and then override these strings. Right, now we created a new sprite. I need to see the syntax for libgdx and creation of new sprites. If you don't know, my personal working habit is I don't try to remember how custom functions work in libraries, because libraries are usually very large, and so I just have a API or a reference next to it, next to my second screen here, that you don't see, and then I'll look at it whenever I need to look at a specific function or a specific thing that I need. So it looks like Sprite has a default constructor, or I could pass in a texture. Alright. So let's not pass in a texture for now. In fact, we'll require it from the user. So a texture must be given by the user, because we need to have a constant default texture. So I should probably make a quick note on that. Must have constant default texture. Alright. So now I can require a texture. Sadly, Java does not seem to have namespaces, so if I have multiple classes with texture, then I am screwed. So let's import texture. And so here we will require texture. and then we'll pass all this to the base class constructor, which will be whatever we wrote in handler. Alright, I gotta hurry, don't have much time left. See if that worked. Alright, what is the problem? It's undefined. It's container object T. Oh, that is correct. I forgot to extends. Alright, now it's gonna complain about not doing these prod things here. So now we need to check how I did that for this. I had resource deleted, which will basically delete the resources. So what we do is we get the array list of all the containers and then use the function that we coded in handler. So now you get to see why I was coding that in the first place, because we need to loop through all the containers and edit its value so that we could change its internal state. So let's do that. Let me create an iterator, call it container. We'll set that to it, and that being the iterator. And so now we use a while loop instead of a for loop. Iterator, import this one, it dash has next. And so since we're importing this from C++, we do not need the pointers. We can just do dot next. Actually, before we do that, we need to have an object that contains it, because like I've said before, every time we call next, it would be a different object. There we go. Alright, so this function basically says function to tell the handler that a resource has been deleted. Change all the container classes to point to a default texture that is unchangeable. And so for those who missed the introduction for the resource deleted, I will, prior to finishing up, I would basically, again, I'll go over the entire code, and hopefully that'll clear up any misconceptions with all these functions and the whole purpose of what a handler does in our class. Okay, so we're gonna set the texture of the sprite, because we basically just said all the containers that have this specific resource file name, we want to change the file name to the default file name that points to the default texture, and then we want to set this sprite's texture to that default texture. Now let's see here. We need to get the default texture. So we call the default container. Let's see, what was the name? Get I remember I implemented this. Here it is. Get def container. Get def container. Dot. Let's see. Container object dot get texture. Here we go. So this is a little bit long. No. Do that. And just so you know, this line on the right indicates 80 characters as the limit that I set. The reason why I set that is just a pet peeve of mine. I don't like it when it crosses 80 characters. Probably because when I was first learning Java from my instructor in college, she basically, almost all my instructors basically said they like that line, and it stuck with me. But if I'm doing C++, I don't have that line for some reason. I'm not sure why. Probably because I self-taught C++, and so I don't have as much as a restriction that I personally feel that I should do. Okay, so this function always returns true for this specific class. There might be other classes that we might extend. If that is the case, it might not always return true. But for now it is. Next we have create sprite, which is also public. Prior to that, let me do something. Static. So these are the variables that we are using for our default places. Again, we're essentially doing what Steam games does, or just source games. If you see those red errors in those games, or those purple textures, that's essentially what this is doing. And we also need a variable that will essentially hold. For those of you joining in, I am trying to import a section of code that I always use in C++ projects into Java. So we need a private texture manager. So this is completely up to the person using this class, but we already created a texture manager to manage our textures, and since the handler is so close to the texture manager, if we give it a texture manager or the reference to that texture manager, we could create two functions that will lighten the burden when we use this class. Because if you look at texture manager, every time we load in a texture, we have to call all this stuff, and it's a pain in the butt. And so what we do is we give it a texture manager, and we just call handler to create sprites for us, and we don't have to pass in a texture for it. And you'll see that in a moment. So I'm writing no need to delete because Java does not have deconstructors, so I don't need to do that. We'll let Java handle that. Obviously, we need the getters and setters. Okay, so this code here is a little bit more unique. We allow passing of null textures, so we're gonna call this and we allow null textures because we will use that to check whether or not we have a texture manager set and whether or not we could use a specific function. However, that being said, we will still return false if the given thing is null, because that way we could check that. So we're going to keep note of that, because that is something that is unusual that I probably won't remember. So we'll call that if the given text manager is null, it will be set to null. And the function will return false. Alright. Actually, since I'm gonna set it either way, I'll just do it here. So remove repeating code and space just for aesthetics reasons. Alright, now we only have one more. Prior to that, forgot that I need a null pointer, or just null here. Oh, oops, should probably do this, which is create sprite, which is the function that we define just for sprite handler, because it's sort of a shorthand, a helper function in a sense, so that way we don't have to keep on typing we don't have to keep on using texture manager and then creating a texture manager, creating a texture and then passing it to sprite handler. Instead, we could just use sprite handler to create sprites that automatically create textures for us. Let's see if the code actually smoothly transitions into Java, because what I'm worried about is if I pass it a Java object and that object gets deleted, no, not deleted, just lost, where does that object lie? No, okay. Never mind, it does work because Java will treat that as a pointer. Alright, so we needed a unique sprite name. This is a function that must have texture manager defined class, or else it will not work. That being said, it is sort of a helper function that creates a texture and then creates a sprite. Just do on their own. So we also need the file name of that texture file. So what will happen is we first check if the text manager exists. If text manager is equal to null, if it doesn't exist, then we return the default sprite. And so now, otherwise, we have to check if that sprite name exists. But luckily for us, we already have a container for that. So we already have a function defined in handler that does it automatically, which is the getter and setters for the container. So we'll just add that in. What else do we need to pass in? Name, the container file, and the object itself. So we will now use the texture manager that we have. Going to load a resource. We're going to load it the specific name and the file name, which oh, this is incomplete code, it seems. Alright, I'll fix that shortly. We'll give it a sprite name, and we also need to give it the texture name. There we go, that makes sense. So now we can do this. File name. Sprite name. Just load resource. Alright, and I think that is it for the sprite handler. We should be able to use it. Let's see here. For argument, string, texture. Oh, we need to sprite, of course. So now we're done with that helper function. We should be able to use it in our main project. This project is how we utilize this class is pretty simple. We first created a texture manager, and then we create a sprite handler. We call that handler is equal to new sprite handler, and then we pass it in a default, I believe a default texture. Yes, default texture. So we use the text manager. We load a default text. Load resource. We shall call the string name to be whatever we call the default file name and resource. Wow, that is very long. Let's cut it here. Alright. And so now we will set the text manager. Perfect. And so now we should be able to call the helper function, create sprite. What should we call this? This should work, comma, bacon. Texture name, add logic dot jpeg, and then the file name. Oh, jpeg. Alright, moment of truth. Probably need to do some debugging. It is a 90% chance that I will probably have some error, as I always do. Alright, I will access this in a static way. Okay, so if all goes well, we should see the same test code that we've been seeing the entire time. Nothing should really change until I add a second line of code, but for now let's see what happens. Yep, it does. Probably forgot to initialize something again. So let's see, line 30. This is the handler class. Yes, I did forget to initialize the containers. So call it string, comma, container. Alright, let's do it again. Let me open it in debug. Right, another exception. See what this time it is. Oops. Sprite batch. Alright. Oops. Give me the error. I should stop clicking on that. It is to the left of me. Stop that process. Never got used to Eclipse for the debug. Sprite batch. 934. Oh, that is correct. We need to actually draw the sprite, not the image. So we need to do we should change the image into a sprite. And so we pass it a sprite. Does that work? No. See what I could do. Need to check the documentation because I don't remember. So what I usually do is I don't try to memorize everything in a library. Instead, I only have the ones that I use most often. Else, I would just check the documentation because I want to focus directly just on my code itself. Alright. So if I believe correctly, Sprite class, I'm going to check the API for libgdx. The Sprite, Sprite, Sprite should have, here it is, draw. Okay, let's try that. Once we do that, we will call it a day because we actually did a lot today. Oh, okay. In fact, do we even need a batch? If that is the case, since we're only drawing one sprite. I guess we do. Will that work? I don't think so. No, I thought so. I need okay, let's see what the error is. Alright, give me that error. 35 draw. Still does not like it. Okay. No pointer exception because I did not set the sprite. Wow. Alright. Alright, it does work. It seems like it's just a normal test page, but it is not, because we actually added a sprite handler. So last time, if you remember from day 2, if we had the texture manager and we deleted the texture becomes dark, and that was perfect. But obviously when we have the game, that is not perfect. So with our new sprite handler class, if we were to unload said texture from our texture manager, and we call that texture should work. Now if we run this, what it's gonna do is we have a texture manager, and that texture manager will go into actually no, we have a texture manager, and then we have a sprite manager, sprite handler, and then sprite handler sets its own internal texture manager, and then using this create sprite class, which is internal, we then essentially create a sprite, and then now that we created a sprite associated with this unique identifier to this texture called should work, which is connected to badlogic.jpg, when we unload that should work, what will happen is instead of having badlogic.jpg, it should change into urtext.png, which is our default texture. No, it did not work. Alright, let's see why. Oh yes, that is correct, I remembered. Once we unload, what we need to do is we need to tell sprite handler that we unloaded something, because that is just how I wanted it to work. I wanted both classes to be independent of each other, and so when we create a sprite handler, it's just a nifty way for us to manage sprites as well as telling them to change the textures in the sprite. So we will say, that is not what we want, we will say resource deleted, and then we need to indicate what resource we just deleted. In this case, we just deleted the bad logic resource. So there we go. We have an error texture instead of that dark texture that you just saw. So that means our sprite handler does work, and that means we had a successful day of coding. Before I go, I'm going to give a brief rundown of what we just did today, and then fix something that I wanted to fix since day 2, and then we'll call it a day. Alright, so what did we do today? Well, if you recall from day 2, we created a texture manager, and that manager essentially created textures and maintain them, so that if we loaded multiple textures of the same file, it would just create one instance of that texture class, and everything would be pointed to that texture. Now, if you look at libgdx, there is something similar to that called asset manager class, but asset manager is way too large for what we need, and also we're creating this project so that we could all learn from this experience, so texture manager is created by hand. Next, this is what we actually did today. Today we created a handler class. Now, like I've said, for the analogy, for most game libraries, we have a type of class called a container class, and we have a type called a resource class. A resource class only contains data for that resource. For example, textures only contain information on textures, nothing else. It does not contain information about the location of that texture relative to the screen, none of that. But that's where the container class comes in with the sprite class, and sprite class will basically contain information on where that texture should be outputted relative to the screen. And so when we have this handler class, it's basically managing all of our container classes. And inside handler class, what we do is we first create a base abstract class, we call it handler, and it is a generic type. So we gotta pass him what type of container class we want. Inside there is a linked hash map, and what this linked hash map does is it actually holds the physical containers